Hello, and welcome to Biocult on campus, the platform that will teach you more about Biocult, sustainable agriculture, and how to work with nature. My name is Chris Hendricks. I'm the International Biological Specialist for AECI, the proud manufacturer of Biocult since 1993. Since the beginning, AECI have been optimizing our Mycorrhizae combination products with the assistance of industry experts, especially in the field of Mycorrhizae, and our in-house research and development team. With our unique in vivo production method and strict quality control protocol, we deliver combination products that have proven consistent performance across the globe, especially in adverse conditions. AECI has recognized that conventional practices has led to the depletion of mycorrhizae populations in the soil. We also believe that we can bring back the life to the soil with products like Biocult that is compatible even with conventional practices. So, endomycorrhizae. What is endomycorrhizae and what is the fuss all about? Endomycorrhizae is supposed to occur all across the world in all soil types. But like mentioned previously, because of conventional practices, we've diminished the populations. Endomycorrhizae has the tendency to associate with most crops, and because of that association taking place on a natural basis, plants then have the ability to perform naturally. So, what makes Biocult so unique? Firstly is the combination of the various species, and then also, like mentioned previously, it's the production method. In vivo production delivers a more robust, hardier spore, which also varies more in size, and then also verges more towards the smaller spore size, which means that these spores, not only are they more viable, but they can move in the soil profile a lot easier. Once mycorrhizae starts populating the root zone, plants now have access to more nutrients and water that was previously out of reach of the root zone. This is based on the fact that mycorrhizae has the ability to expand the root surface area by 7 times on average. Because the plant now has the ability to absorb more nutrients and water, the plant is now supported to produce a larger factory. And in essence, because it can produce more nutrients to fill the grains or the seeds or the fruit, it can produce a better quality yield and also has a higher yield potential. And in addition to that, because the mycorrhizae works in the soil and is part of the carbon sequestration process, it also improves your soil structure and also adds to the diversity of the microbial life. A very important difference between Biocult and similar products on the market is the lower dosage rate. The reason for this being, like mentioned before, the in vivo production method delivers a spore that has a higher viability. This means that the spore can survive in the soil for a lot longer, and given the smaller spore size, allowing the spores to move through the soil profile a lot easier, you can lower the dosage rates as opposed to larger spores with lower viability, which means you need to increase that dosage to get the same effect. Stay tuned to this channel for more Biocult content.
I'm Karin Jacobs. I'm a professor of microbiology at the University of Stellenbosch. I have a PhD in microbiology, but I have been trained as a mycologist. And that, for those of you who don't know, is people who study fungi and the taxonomy and their relationship in nature with other organisms. So the microbiome is a collective term for the microorganisms that lives around. Say, for instance, we're interested in the rhizosphere microbiome. So we are interested in the organisms that lives in the rhizosphere, which are the little bit of soil just adjacent to the root systems. And those organisms are critical in nutrient cycling, and particularly in agriculture, it is really important to understand how they contribute and change with different management practices and different crops and different environmental conditions. Because they do have, if you look after your microbiome, you can actually mitigate a lot of climate change problems, droughts, nitrogen stresses, and various other issues in agriculture. So mycorrhizae in general is a term that we use for fungi that associates with the roots of plants in order to establish a symbiotic relationship. And there are different types of these mycorrhizae. So we have the endomycorrhizae, and those are the ones like the avascular mycorrhizae that goes inside the root. And then we have the ectomycorrhizae that goes around the root, and those are mostly bacillomycetes or mushrooms. So if you see mushrooms on the trees, for instance, you can dig down and you'll find that they are on the roots of the trees where they assist with nutrient acquisition. It is a fascinating group of organisms that has evolved with plants over millennia. It's estimated that this group, particularly the avascular mycorrhizae, are about 450 million years old. That's quite an old group, and we know this because when we dig up fossils from plants, we can see these organisms in the roots of these plants, and they fossilize there. So the hypothesis currently is that they allow plants to grow onto terrestrial systems and reduce the amount of carbon dioxide in the air to a space where other organisms can also flourish. So they're integral in the evolution of organisms over a very, very long time. These mycorrhizae are extremely effective in picking up phosphorus and nitrogen in a format that the plant can use, particularly in soils that are very low in these nutrient sources. And we see a lot of this happening in, for instance, feinbosch soils, where we have a natural oligotrophic environment, which means we have a natural environment that is very low in nutrients, particularly nitrogen and phosphorus. The plants have evolved to grow there, and to do that, they have made these connections with mycorrhizae. How does the association really works? Basically, if we have to break it down to a very simple explanation, it is a chemical signaling between the fungus and the plant in order for it to associate. But for order for it to get into the roots, it needs to infect this plant. And most plants don't like infections. They try to build up the immune systems to prevent infections in their root cells. So they would then, so the plants will excrete a hormone or a molecule called strigolactone into the soil environment, which is a signal molecule for the fungus to associate with the plant. It will grow towards the plant, and then it will excrete its own signal molecules to the plant to indicate that it needs to switch off their little alarm system right there so that they can associate. They will go up to the root, and then they form this big foot-like structure, and we call that the hyphopodium, which means fungal foot. So hyphopodium, this structure is actually quite unique in that not a lot of fungi do that. Actually, very few fungi do that. Mostly they have another type of structure there, which is much smaller. So we have a big flat foot there, and then that would germinate into the cell. And then you'll see these hyphae growing in around the cells, where they eventually will grow and germinate right into the cells. So there's a layer there between the root cytoplasm as well as the fungus, and within that tiny little layer, which consists mostly of fungal material, that's where the exchanges takes place. And if you really think about this, the scale at which this takes place, it is absolutely astonishing how this evolved over time.
Hi guys, my name is Garth Kutsi. I'm a farmer in Mashonaland East, Zimbabwe. I'm the director of Chippenberry Agri. We've been farming on this farm currently, Snow Sprite Farm, for about 5 years. We grow tobacco and potatoes on this farm. So with regards to plant nutrition and health, we have started using biological products for the past 2 to 3 years. We get it through a distributor in Zimbabwe. This has helped reduce the more harmful chemicals that we put on our crops. So going into a bit more depth on Biocult, what we've noticed this season is a dramatic change in the root development of the seedlings in the tobacco seed beds. We found that there was a lot more root mass, and in particular more finer root hairs, if I can call them that, attached to the end of the bulk of the roots. It gives the seedling, when we plant them out, a very good start when we plant them. Obviously, the more roots you have, the quicker it establishes, and we have less deaths occurring in the lands, which leads to less replanting as well. So some of the benefits we're seeing on Snowstripe Farm is in our seed beds for our tobacco. This year, 2023, has probably been it has been our best seed beds that we've grown for our tobacco. It's very important. That's where it all starts from. Good seedlings gives you the step in the right direction. On the potato side, we apply it at planting. It's applied through a spraying system in furrow, and it is applied directly into the open ridge over the seed potato, and it is closed immediately after that. With the potatoes, we've seen a lot more even emergence coming through using Biocult. And the same things we're also seeing in the potatoes that we saw in our tobacco beds. Really good root mass, and those fine root hairs coming along. The populations are quite high. The potato population is twice as high as tobacco, and it is very simple to apply and very practical. And it's fairly accurate. So with regards to apply it, we don't find any trouble in applying Biocult. It's easy to use, and like I've said before, the benefits are there. It's a fantastic product. So with Biocult, we use it on both farms, with both tobacco and potatoes. We've been using it for the past 2 years, and we'll continue to use it going forward. So my advice or recommendations to other farmers out there would definitely be to explore the more sustainable side of farming. Biocult is a very good start. I would also recommend minimum tillage. I would also suggest incorporating cover crops. The research is there, it's proven it helps. So at the end of the day, we farm to make profit, and that is the main aim. If you reduce your yield and you reduce your costs, the profit is still there. So, and that's where Biocult helps so much, and the sustainable agriculture helps so much. Is you thinking of the bigger picture, and you're working towards your profit. You can be sustainable and still make a good profit, and still produce good crops with good yield and good quality.
Hello, my name is Murray Barlow. I'm the CEO of Rustenberg Wines. We're a family-owned and run operation in Stellenbosch in South Africa. The estate's been in my family since 1941, and we farm together as a family. I farm with my father, my mother, my wife, and we have a fantastic team here at Rustenberg. Rustenberg's got a lovely long history. It's very much tied to the founding of Stellenbosch in 1679. The land was first farmed starting in 1682, and we have proof of our first wine being made here in 1692. If we look at our records during the Dutch era of occupation, most of the products that were made here were brandy, fortified wines. Later, when we see the influence of the British after the Napoleonic Wars, we produce a lot of red wines. And coming into the modern era, we now produce half white wines, half red wines. We also have a herd of cattle, and that's what we farm today.
Hi, I am Tessa van Zyl. I'm the viticulturist here at Rustenberg Wines. For our planting program, we use Biocult, the mycorrhizal fungi, and we use that in the plant while we're planting. We've been using Biocult since 2015 when we started planting. And when I learned about mycorrhizal fungi, and I realized it's quite an incredible product with this diverse sort of communication network under the soil, and sort of scavenging of trace and elements and for the vines. So we actually started applying it in planting, and how we do it is we dig a hole and we put the vine in and we throw the Biocult onto the roots, and then we cover it up again. So it's a very, very easy, simple way of application. And we've always been using it. I've never not used it. So it's quite hard to say what it's done specifically, but I know we're always going to use it because I know that mycorrhizal fungi is an incredible product, an incredible fungi. So we will continue to use it, and as you can see, these are growing beautifully. And you can see this, the soil is amazing. It's got an incredible texture. It's beautiful soil. Yeah, we're lucky to work with it. Some of the benefits of mycorrhizal fungi are that it forms a symbiotic relationship with the roots of the vine, and that sort of extends the root system out, which helps it acquire more nutrients. It mines nutrients for them. It acquires sort of nutrients that are immobile and the vines might not be able to access. So it really just gives it that extra support for the vine. And then it also can stimulate the immune response of the vine as well, and make it sort of more robust immune system. The relationship between the mycorrhizal fungi and the vine is so important and so beneficial, especially at this planting stage, because it's quite a vulnerable vine. It's still got to grow up and be trained, and we don't want it to be under stress. So that relationship will prevent the stresses of water stress or anything like that. And also with disease, early stages, these sort of soft leaves can be susceptible, so that sort of immune response that it initiates is really helpful. Going forward, for Rustenberg, we will definitely continue to use mycorrhizal fungi. I trust that this mycorrhizal fungi is really supporting soil life, which is really probably one of the most important things in vine longevity, yield, and all of that. So I would encourage everyone to consider using mycorrhizal fungi because of the benefits of it.